Hello, this is Mr. Rasmussen with Algebra 2 and Lesson 117. This one here, we're going to go through and review our different sets and subsets of numbers. Our most exclusive set are our natural or our counting numbers. That just is 1, 2, 3, 4, all whole numbers. And that's designated with an N, which is our 1, 2, 3, our counting numbers. Okay, and then if we add 0 to our counting numbers, then we have a W, which is simply our whole numbers there. And then our next larger category, they use a J as the variable, abbreviating it, is our integers. So that's like -2, -1, 0. It's all whole numbers, but it also involves our negatives. So that's our integers. And then we have Q, which stands for rational numbers. That's all of our numbers that can be expressed as a fraction. They use the letter P for our irrational, all the numbers that cannot be expressed as a fraction, but they keep going and going. We have an R, which stands for all real numbers. And then we have a C, which stands for complex numbers. Remember, complex numbers are the numbers that have this I in there as an imaginary part. Okay, so based upon that, so far you've seen some problems if we look there in the book, like x plus 2 is greater than 4, and then the domain is integers. Right, so we've looked at it as a domain, and so we can actually write that a little differently. They could say set A, just as a generic thing there, and then a little bracket there. X has the elements of J, so J is our variable for integers, and then we put a line, and then we can write our x plus 2 variable for, and then that there. So that would read, A is the set whose members are integers, J, such that, this line is such that x plus 2 is greater than 4. And that's how that would read. So, but that is no different than pulling this out. So if they asked us to graph that, we'd get x by itself, subtract 2 from both sides. So basically x is larger than 2. So we put 2 on our number line there. It doesn't include 2, so an open, I was going to put an open circle, but since it's integers, okay, it doesn't include 2. We basically start with 3, and this J right here would tell us that it's integers. So basically it's just a different way of writing it. Instead of writing integers as domain, they're going to put the letter J in there, and you're going to have to know what that means. And so we just have solid dots there going larger, 3 and larger, 2 is not included. Okay, let's take a look at example number 1 there. Well, the only example, and this ends up going on a graph, so I'm going to pull out a piece of graph paper here. All right, so they give us a little bracket there, x comma y are elements of R. So what is R? If you look, R is all reals, so that's the same thing as writing the domain as reals, okay? And then such that y is anything larger than x plus 2, and y is anything less than negative x. Okay, so this here, and an end brace. So this there looks a little confusing, but basically all this is telling us is that both of them are in the domain of reals because of the R, and then these separate out, and we use slope-intercept form to be able to graph those. So let's put those on here. This one here, our intercept is 2, right there. Then our slope is a positive, understood 1 over 1. So go up 1 over 1, up 1 over 1, and then basically like that. Then, since we don't have an equal sign there, we have an inequality. We got to look and see what it is. Well, it doesn't have the straight line, so it's not equal to, so we're going to use a dashed line to go through here. All right, so there's a dashed line. Show that it's not part of that. Okay, then we're going to graph our second one here. It doesn't give us an intercept. Do you see that? So it's understood that it's 0. Then for a slope, it's a negative understood 1 over 1. So right here doesn't have the equal sign for inequality. So we're doing a dashed line that comes through 0 and a negative 1. So it's going to go down. So down 1 over 1, down 1 over 1, down 1 over 1, and something such as this. Okay, so we got our two lines graphed there with our slope and intercept. It's basically the same thing. Y equals x plus 2, 1 over 1, right? Y is equal to negative 1 over 1 x plus 0 is the way it looks. However, because there's not equal signs, there's our inequalities, and it's not equal to that, just gives us our dashed line, but besides that, it's all the same. Okay, now that we've graphed those, we have to shade a certain part. And I know you've been, I think, this can be some trouble for students as far as figuring out where to graph. So I decided I'm going to pull out the colored pencils here and do some quadrants. So let's make a blue quadrant. There's that color, there's blue. Let's make that one top one blue. Let's do a green quadrant. Let's make this one green. Okay, let's do yellow. Here's yellow. Let's make this one yellow. And then let's do red. Okay, and let's make this one red here. Okay, so we've got our 4 spots, and we have to pick one of those to shade. But I want you to see what each one kind of represents there. So let's label this first. Let's label this equation. Let's label this number 1 equation and this number 2 equation. Okay. So here's number 1, number 2, number 1, number 2, number 1, number 2, and for the last one there. Okay. So for this first line here, okay. As you see, so this equation here, this is line number 1, and this one is line number 2. Okay, so for this one here, okay, can we see that the blue and the red are both above? The blue and the red are both above line number 1. And then the green and the yellow are both below line number 1. Do you see that? Red, blue, above this line, green and yellow below this line, okay? Then if we look at our second line here, line number 2, we can see that blue and green are both above. So lines here, blue and green are both above, and red and yellow are both below. Okay, and so from that we get our 4 different combinations. So our question is, which one of these 4 do we shade as our answer? Well, let's look at this here. This one here, y, the y variable is what counts. So if we look at equation number 1, y is greater than our equation. Y is larger, greater, above. So basically in our first equation, it has to be above it. So if we look here, yes, number 1 here, no. So this one, automatically this equation doesn't work because number 1 equation has to be above. So the green one's out because that's below. This one, number 1, is below as well, so the yellow one's out. The red one here for number 1, that is still above. Okay, so we see that for this one, y has to be above. Then for this equation here, it all has to do with y. Y is less than the rest of it, so y being less than, y is below. So if we look at first equation here, second equation, this second equation says that y is above, right? Blue is above line number 2, so that one's out. These ones are already out. This one would be out because of that. This one, number 2, is below. This one's below. So the only one that's left that works, even though number 2 is okay for this one, it's not okay for number 1. The only one that works where it's above the first line and below the second line, okay, see how red is below, is this answer right here, where we're in the red section. So above line 1, below line 2, and we would shade this part here as our answer, right here, as our answer. And the red spot. Okay, that being said, let's go ahead and try the practice problem. And then once again, I'll do it myself, and then you can compare. So the practice problem here, X is the element of J. Oh, I don't need a graph paper for this. Just realized that. Grabbing the graph paper. All right. Let's grab another sheet here. Okay. X is the element of J such that X plus 3 is greater than 5. Okay, so what do the J's mean? Well, if we come back over here, J's are integers. So that's the same thing as writing domain is integers, which means just whole numbers, right? Okay, so then we come over here and we subtract 3 to both sides. We get X is greater than 5, so let's graph that. It doesn't equal 5, so here's 5. You could put an open circle, but you really don't have to. X is greater, so we're going to come to 6, and our first number is 6, and anything larger, 7, with closed circles on all of the whole numbers or the integers and an arrow going that way. Okay, I feel like that looks all right, my answer key is telling me that that is incorrect. Minus 3. Oh, right. I didn't subtract the 3. Okay. 5 minus 3 is 2. There we go. Okay, so actually, right, you maybe caught that while I was saying that. Didn't actually do my math there. I graphed X is anything greater than 5. If X is anything greater than 2, so here's 2. It wouldn't include 2, but it would start with 3, then 4, then 5, and go that way as whole numbers. All right, we got it there. If you have any questions about this, please feel free to contact me. Have a great day.